Hi, there you are. Good morning. I was just finishing my coffee, so I think it's perfect timing. Welcome to today's event. My name is Maria. I'll be your moderator, and this is Trelleborg Connects. Today we are live streaming from our Innovation Center in Stuttgart. Today will be everything about collaborative innovation, solutions in silicon technology. And as I walk to the set where the magic will happen today, I just want to tell you what's in store for you today. So we brought all our silicon experts together in Stuttgart, and they will be talking about silicon as a material, silicon technology, our capabilities in this area, our manufacturing footprint. We will have a panel discussion, we will have keynote presentations. But what I am the most excited about, it's a virtual tour. So we will be taking you to Switzerland with us to visit our high automation, high technology manufacturing facility in Switzerland, in Stein am Rhein. I've never been there, so I'm super excited. So as you can see, lots happening behind the scenes, and now we're walking to the set. So this is where the magic will happen. Welcome. And speaking of Switzerland and speaking of moderating, I didn't want to stand here alone. So I brought someone with me. I have Jarno Burkhardt, our general manager from Stein am Rhein. So Jarno, you will be with me today.
Yes, I'm super excited, Maria. Thank you for having me.
Hello. Course.
Good morning.
Then I don't have to stand alone here.
No.
Thank you so much for that.
My pleasure.
So, Jarno, I was just telling our audience, today is all about collaborative innovation. Yeah. What exactly do we mean by that?
Actually, to me, collaborative innovation is when two parties develop a new product together, where one party helps the other in developing a material, a product, a solution, which is not available on the market yet, to make it work.
So it's about partnering with our customers or potential customers and creating an innovative solution for a particular application.
Exactly,
Correct.
It is exactly like that.
Yes. Wonderful. And we have our experts who will be guiding us through almost everything about silicon, so what the material is, how do we manufacture, or which capabilities we can offer. What are you the most excited about today?
Actually, I'm really looking forward to the keynote, which we hear later on, because it is exactly about shoulder-to-shoulder development. And then also followed by the panel discussion, which takes that even further by practical examples, how we did it, how we do it. So this will be exciting.
I was telling the audience I'm very excited about going to Stein am Rhein, actually. I've never been there. So we're going to take a virtual tour with you and with Caroline, who will also join us later. And before we get the party started, a little bit of housekeeping. So we are recording this live event. We will make the link available to you so that you can watch us again, or maybe share with someone who couldn't be with us this morning. This is an interactive event, so we are happy to receive your questions for our speakers. So on your screen, you will be able to find a live chat function or menu. Just open that up, and if you have any questions, just type them in there. I will collect them, and at the end of each presentation, we have a Q&A, so I will ask those questions on your behalf. Also in the live chat, you will find information from us. There will also be a short survey that you are welcome to fill in or answer, but that will happen later. So now I think I am done with introductions. So Jarno, I will see you again later. And we're going to start with our first presentation this morning. So one of the many experts that we have today here for you. Again, please feel free to use the live chat whenever you have a question. Of course, we can't discuss any commercial information, but we will reach out to you in case we can't answer your question live in this show. So let's kick it off. I will welcome now our first speaker this morning. I have Andrew Thomas. Good morning, Andrew.
Hi, good morning.
I'm going to try to say a word that I struggle with. You know which one. So you are our technical manager in Trelleborg Sealing Solutions, Webley.
Webley,
perfect, in the UK.
Yeah.
Welcome.
Wobbly.
Don't get me started on that. It's nice to see you again.
Nice to see you too.
And Andrew, as a technical manager,
Yep.
You are the expert in materials and silicone and all these things. So today you will be taking our audience on a little trip.
Yes.
correct?
Yes, that's
Into
correct.
the world of silicone.
Yes.
And silicone technology.
Yep.
So please feel free to ask your questions throughout Andrew's presentation. And that's my cue to leave the set and take the stage.
Thank you. Hello, everybody. As Maria has already introduced me to you, but my name is Andrew Thomas. I am the Technical Manager of Trelleborg Sealing Solutions Webley. And today is my pleasure to be talking to you about silicone technology. Now, I'm sure you can appreciate silicone technology is a very, very broad, often complex subject. And so let's jump straight in at the start and ask two questions. What is silicone and where does it come from? So, silicone as a material is derived from the chemical element silicon, of the periodic table, atomic number 14. Now, silicon, I have an example here, is actually, to you and I, looks like a metal, but is actually classified as a non-metal and is a metalloid. Now, this is because it exhibits not typically metallic-like properties, which is quite unusual, but does also give rise to the special characteristics of the material, as we will learn to explore later on. And just one other point to note as well, silicon doesn't have the E on the end, silicone does, and this is after the synthesis, the process which I'll describe to you now. So another interesting fact is 1/4 of the Earth's crust consists of silicon. It's very abundant. It is actually the second most abundant element on the surface of the Earth. But you will never find it, or very rarely find it, in its pure form, as you can see it here today. This is because it commonly exists with oxygen as a compound. Now, typically, we know this as silicon dioxide or silica. Examples of this, of course, are sand and quartz. Now, there isn't really any shortage of this material, as you can imagine, it's quite abundant. But in order to extract the silicon from the silica, we need to go through a process of refinement and effectively a chemical reduction that takes place at around about 2,500 degrees. As you can imagine, that's quite an energy-demanding process. So once we have extracted the silicon, we then go through a complex upstream process where the silicon metal is transformed into a siloxane prepolymer. Now, this siloxane is known as polydimethyl siloxane, or perhaps more easily to say, PDMS. Now, PDS is an optically clear, inert, non-toxic fluid. I think it's quite important to say that those 3 bullet points there do cover a lot of very complex chemistry, and quite honestly, it's difficult to envisage how this metalloid is transformed into a clear, colourless liquid. But it does happen through a case of chemical exposure to chlorosilanes, methylene chloride. It goes through a reactor. And so what we get is this fluid, PDMS, and this is the precursor polymer for all types of silicone. And this is where we add the E onto the end. Now, silicone is a very versatile material. It can be an oil, it can be a caulk, it can be a grease. But what we're talking to you about today, and of interest, I think, most to Trelleborg, is as a rubber. So, silicone rubber, designation VMQ, or sometimes MVQ, is a very, very specialist elastomer which has really quite unique characteristics and performance. Why would you choose silicone rubber? What is special about this material? Well, I think the strap line at the bottom covers a lot of it. Silicone is used everywhere, all around the world, in all different applications. One of the key benefits of the material is it has this outstanding temperature resistance. So silicone can see temperatures as high as 315 degrees, and in some cases higher for shorter periods of time. Conversely, it also remains flexible down at minus 110 degrees C. So this huge temperature range is not matched by any other elastomer at all. It has outstanding environmental and hazard resistance, extreme weather, flame retardants, chemical and media resistance. This can all be improved with specific additives and formulation improvements as well. It is a radiation-resistant material and can be sterilized via all forms, E-beam, gamma, ion, autoclave. It's an incredibly versatile material, and this is, I think, is one of the most important things to consider with silicone. Effectively, it can be custom tailored. There's a wide range of grades to choose from. The properties and the potential for pigmentation are vast. It really is quite a remarkable material in terms of what you can do to it. And then ultimately, it's an incredibly reliable material. It's industry known, it's industry recognized, it's inert, it's stable. And this is why it's a key material to so many different industries: aerospace, automotive, HVAC, electronics, food, water, the list goes on. It really is quite a crucial material for the world at which we live in today. So there are different types of silicone rubber, and what I have tried to present for you here is just a basic snapshot of the way in which silicone is broken down as an elastomer. So if you look to the right of the screen, you'll see we have these room temperature curing materials. Now, these are the types of grades that are more commodity. They tend to be used in building and or where you need to seal around your shower or your bathtub or your sink at home. These grades are available in stores, your warehouses, and of course, Trelleborg are involved with these materials as well. But the real key point of what I am talking to you about today is the heat temperature curing materials. Now, these are split into two. We have the high consistency silicone rubber, which is either referenced as HCR or HTV, and we have the liquid silicone rubber, both of which are critical to everything that Trelleborg are doing for our customers. Now, we break those down further. High consistency silicone rubber can be catalyzed via ionic chemistry with peroxides or addition chemistry with platinums. LSR can only be catalyzed with platinum, and this gives rise to some differences to consider, but there are multiple options. So what are the differences between HCR and LSR? What is liquid silicone rubber? Well, as the name suggests, it is a liquid or liquid-like form of silicone rubber. It has a lower molecular weight. Chemically, they're very, very same. They have actually the same chemical backbone, but the way in which it's polymerized gives rise to this very low molecular weight with LSR. Much shorter chain lengths, which in turn allows for better flow properties, lower viscosity, enabling intricate mold flow. It is obviously a high purity material, and as I mentioned before, platinum catalyzed. It typically is also supplied in two parts, A and a B. Now, these tend to be 50-50 mixing ratio, but not always the case. But generally, LSR is supplied in two parts. In terms of the advantages of LSR, there are many. One of the key aspects being it has this very, very fast cycle time potential. In order to really optimize your process, it is capable of incredibly fast cycle times, akin to plastic molding. It enables intricate component manufacture because the way in which the material flows, it really is possible to create some very complex shapes. There is often no need for secondary finishing. So once the molding has taken place, it can then go straight through to the next stage. There is more availability of automated equipment and ancillary equipment associated with liquid silicone rubber. Multi-component injection molding is possible. In fact, our colleagues will talk to you about this later on today, but it is possible to injection mold liquid silicone rubber, plastic, metal, and so we get this very complex device. It's also really suited for economical, high-volume output. If you really do need to produce millions and millions of parts in an economical manner, then liquid silicone rubber really is the choice material. Now, there are some considerations with liquid silicone rubber. Generally, the tooling cost is much higher, and the reason for this is that the accuracy of the machining is incredibly important. Surface ground finishes and so on and so forth. This leads to longer lead times, but the tooling cost, as I mentioned, is higher. There are a narrower range of grades available. There are lots, but it is still slightly less than is what can be done with high consistency silicone rubber. There is limited or more limited opportunity for pigmentation and further customization. And the reason for that is due to the viscosity and the nature of the material. The more we add to it, the more viscous it becomes, the more difficult it becomes to process. It's not typically suitable for processes other than molding. So it's not common to extrude liquid silicone rubber, for example, or compression mold with it as a material. Now, high consistency silicone rubber is perhaps a little bit more versatile. So what is high consistency rubber? Well, it's a solid form, chemically the same as liquid silicone rubber, but a solid form of the same material. It can be vulcanized with either peroxide or platinum, which allows us to go through different processes. It does have an increased loading of silica, which gives rise to the increased viscosity, longer chain lengths, higher molecular weight. This feels like a different material. It looks more like a traditional rubber, as we would say. High viscosity, as I've mentioned. The advantages of HCR are vast. It delivers more design flexibility in terms of what you can do with it. There's more opportunity to customize, tailor, blend, tweak, alter the formulation than there is with LSR. Normally, it is lower cost per kilo, which is of an advantage, of course. Tooling is generally lower, shorter lead times for the reasons I explained before. And there are, again, as I mentioned, multiple catalyst options which give rise to lots of different manufacturing processes. So high consistency silicone rubber can be compression molded, transfer molded, injection molded, extruded, bar weld extruded, calendared, hand fabricated. The list goes on. Specialist manufacture also. It really is an advantageous material to process. So silicone rubber within Trelleborg is obviously really, really important. Trelleborg has extensive expertise on all aspects of silicone material science. This covers both the high consistency material and the liquid silicone rubber, and indeed we are processing these materials across multiple sites. Trelleborg's capabilities and manufacturing process really do cover all of the aspects I've mentioned, and across a global footprint as well. Trelleborg really is an outstanding partner for all of your silicone rubber solutions. And I hope, as we come towards the end of the presentation, that there are some objectives that you can learn from today. I hope you understand what silicone is, how silicone rubbers are derived, where it comes from, why silicone is such an increasingly important material to a whole range of industries, how the different variants of silicone rubber are used, why you would use them, and what are the design considerations between the two materials that I discussed, high consistency silicone rubber and liquid silicone rubber. And finally, Trelleborg is a perfect partner for all of your silicone collaborations, and we're very keen to talk to you about any issues you may have or any interest you have in the material. Any questions, please contact me. And other than that, I'm finished.
Hello again.
Hi, Maria.
Thank you, Andrew. I already have some questions for you, so it didn't take very long. Yes. Wonderful. Are you ready?
I am.
Perfect. So,
I'll try to be.
we will figure it out together. So if the person who asked this, so if I don't know which type of silicone to use, now we know that there's different types of silicone. I did not know that.
Yes.
Can Trelleborg assist in selecting the most suitable and cost-effective option?
Absolutely, yes, absolutely. And I think that's a really good question because it is a very versatile material and covers a whole, as I described, different processes. There are different grades to choose from, different grades within grades as well. And so I think that the key point to note here is that the more that we can glean from the customer in terms of their requirements, what the material needs to do, how it's going to be used, how many parts they want, what sort of volumes are we talking about. This is where our expertise will assist them and guide them to the right material. We will specifically tailor that material and the process to suit their requirements. And so I think it really is critical to understand as much as we can at the front end. And this is why important open dialogue with the customer is key.
And I think we will hear about that later in the panel discussion as well. The more we know about our customers, the better we can assist or partner.
Yeah, absolutely. The more they're willing to share with us, many customers know exactly what they need in terms of the silicone, but for those that don't, dialogue with us will help you understand what it is you need, and we will be able to guide you.
Sounds very good. Next question. So you were talking about different industries.
Yes.
Because silicone is basically everywhere.
Yes.
Almost.
Yes.
So does Trelleborg have silicone experience in all of the industries that you were pointing out earlier?
Yes, we do, absolutely, yeah. So Trelleborg really are, the organisation we all know, a vast organisation, involved in many, many different areas, different segments, different industries, and silicone is key to all of those. So I mentioned aerospace. Silicone for aircraft is an absolutely critical material. Silicone for medical applications is really important because it's inert, it's biocompatible, it's very stable. Silicone can be a very high temperature and low temperature resistant material, as I described, so it can be used in applications where heat is needed, where cold is experienced. It can be a flame retardant material. So honestly, silicone is used in all of the industries that I mentioned, and Trelleborg are heavily involved in those industries as well.
And those industries that you were mentioning are very critical, right? And also the operating conditions are very demanding, I would say.
Absolutely, yeah. So many of the industries and the parts that go into those industries with these materials are safety critical. And so, it's an absolutely important material, essential material.
I think we have time for one more question, or even two, if you're fast. So, are there any instances where you wouldn't recommend silicone?
Yes, of course there are. I mean, there isn't really one material or one elastomer that does everything. Not too many of them. And so silicone is an incredibly versatile material. But for example, if you needed genuine oil resistance, you may not consider silicone as your first port of call. So it may be better to select another material. And again, this is where Trelleborg will advise you. The more that we know at the front end, the better we can help in selecting the best material for you. And if it isn't silicone, we would be able to suggest something else, an FKM, an EPDM. All of the elastomers which are in existence are processed by Trelleborg. So again, this knowledge is key.
And you were pointing out other materials. I mean, we brought you guys, the experts in silicone, today with us, but we have experts in many, many other materials.
Absolutely, yeah.
So if it's not silicone, as you were pointing out, you would be able to refer the customer to another team or another expert.
Absolutely, yeah.
Within Trelleborg.
Yes.
Well, you were very fast in answering,
was
so
quick.
let's take the second one. Good. So we've been talking about LSR and materials, our material expertise this morning. But what about the development? Do we develop this material or do we work with other suppliers for this?
A bit of both, but certainly Trelleborg now have the capability to develop the material as well. So with the high consistency form of the material, the site where I work actually based at Webley, our expertise is in custom formulating for bespoke compounds. So we are creating compounds, the material, that is used exactly as per the customer's requirements. And this is where we were able to really modify and adapt and tweak the formulation in order to give the customer exactly what they need and for it to be processed exactly how they need as well. So we are custom formulating these materials for the application they're intended for.
Great. Thank you very much.
Okay, no
I
problem.
will see you later again,
Okay.
Andrew.
Thank you, Maria.
Jarno, welcome back.
Hello again,
So
Maria.
I'm not alone at any minute of the
We
day.
don't leave you alone,
Perfect.
no.
What did you think of Andrew's presentation? For me, I'm not an expert in materials at all, but to be honest, it was very surprising how we have different types of silicone and also how we add the E at some point in the process. So what do you think, Jarno?
I think absolutely fascinating because me, myself, I do come more from the processing manufacturing side. But as a whole, of course, if you want to advise a solution for application, you need to be expert in understanding the application, in processing, but also understanding the material.
Right.
And I think we have really all of these capabilities all together. And the first part we have impressively heard today.
Yeah.